Hi, good afternoon, everybody. So, under this title, National Climate Policies and Inequality, a Household Perspective, I'll try to present work done by several members of the project in a presentation prepared by Jens Ewald, Simon Fein, Thomas Turner, and myself. Our objective here is contained completely in the title: adopting a household perspective to evaluate national climate policies. In this sense, the exercises we present require at several steps, individual or household data. The talk is organized first presenting the tool, where we describe how it works and the opportunities and challenges the literature of microsimulation model offers for its use to be useful to evaluate the effects on inequality and poverty. And in the case of chips, those related to climate change and to climate policies. So most of the questions we are interested in answering fall in one of the 5 categories you have in the slides. Those could be associated with different perspectives about fighting against inequality and poverty. We can address the first 2 using standard microeconomic tools. The following 3 refer to 3 kinds of macro policies, which of course have important consequences for the individuals. The first, point 3, is concerned with policy-induced changes in the economy. The 4th includes, again, questions of aggregate demand. Just for instance, the target of inflation in a country with a strong potential consequences for inequality. The last one is a kind of drawer of Taylor's box, which is not usual to find in economic modeling, but it has many consequences for inequality. It includes the main questions we have been trying to answer during the development of chips. Sometimes we have also considered necessary to have available policy parameters before answering these questions. And of course, we relied on household budget surveys. So to address questions of the nature of the first and 2 and point 5 also, and their implications for inequality and poverty, we can rely on a microsimulation model based on household microdata. Household microdata is the box HBA's population pre-reform, household budget survey populations. But sometimes we have also administrative registers. Once we assume we have a policy or a shock or an hypothetical or real reform, the box named simulation, we construct the new variables for each individual in the dataset. We name it HBS mode population post-reform. Usually, the institutions providing the data build the ratio of the size of the population to the size of the sample in each census unit. This is named grossing up factor. These factors available for each household, for each individual, allow us to construct aggregate variables to compare pre and post the policy or the shock. This is what we call it here an aggregate of individual situation, and then we can compare them. The difference between the 2 situations described under partial equilibrium in the previous slides and in this slide is the non-adjustment or adjustment of the behavior of the individuals, what we name here microeconomic model or elasticity. This does not mean that we must compute an elasticity, but that the behavior of the individuals allows us to compute it, although we can take this elasticity from the literature, for instance. An unexpected exogenous shock or an unexpected policy change is going to produce more in after effects when individuals cannot react or adapt to, at least in the short run. But exogenous shocks also produce long-run effects for which the individuals can react and adapt to. And so it's convenient sometimes to fit a model to collect this process. The tool could be as simple as in the previous two slides, but it could also be extended to include additional information, trying to capture all the effects that the Polish shock can produce, they be either direct, indirect, or induced. And you have two possibilities to complete the model in the 2 points you have here. Just give an example of what's going on here. We can consider a cyclone which affects income of the individuals. Then, since GDP is the sum of income for all the individuals in a country, if it's going to affect country's GDP, and it could reduce public expenditure by a reduction in direct tax payments, for instance. Public expenditure reduction could further reduce income through reduction in transfer. This is an indirect effect. Or through increasing unemployment rates. This is an induced effect. So we are going to be able, if we combine adequately data not only from household budget survey, to give more responses at different levels and with different effects. The second part of the presentation is devoted to 4 different exercises done during the project period. 3 of them are published papers, and the 4th, application 3, is work in progress, which we expect to be a publishable paper soon. The applications are for Mexico, the first one, the European Union as a whole, the second one, Spain, the third one, and Sweden, the fourth one. For the first application, we choose to study the distributional impacts of carbon taxation in Mexico. So why we do this exercise for Mexico? There are many reasons. Together with the commitment of the project to include some country outside the European Union, first, Mexico is a country very affected by tropical cyclones, for which it could be very useful to produce policy parameters to be able to derive inequality and poverty elasticities. Mexico is also part of the OCDE, is a middle-income country, and probably is going to be given climate risk recipient group of countries of funds. Third, among the commitment of the Paris Agreement, the signatory countries agreed to reduce greenhouse gas emissions, and Mexico committed unconditionally to reduce them by 22% in 2030, compared to baseline scenario of 2013. 4, the evolution of energy-related emissions are not as expected, and commitment to reduce them is crucial to achieve the significant reductions in the coming years. And 5th, Mexico initiated an energy reform before the Paris Agreement, which the aim of substantially transforming its energy sector, but it was in 2013. And it extended for several years. So the current government probably is not following the previous strategy. We are lucky to have Mexican data, and the previous explanation of the model is here. We have a pre-reformed sample of a Mexican survey. We assume a simulation exercise with 2 different carbon taxes. And then we produce elasticities of demand to be transformed in elasticities of poverty and inequality to compare the population pre and post reform. Here is just a slide of the results of introducing the 2 reforms. Of course, the 2 are modifying the prices of gasoline, electricity, and liquefied petroleum gases, because diesel is not an alternative for consumption of for private transport in Mexico. And the increasing prices goes when the carbon tax is $25, gasoline, electricity, and LPGs increased by 5.70%, 10%, and 10.49%, and more than double these amounts if the increase is $50, because we have a non-linear demand structure. With us, concerning inequality, the first reform with the second compensation schemes. The first compensation scheme is a lump sum given to all households. The second one is compensate only households in the three bottom deciles of the income distribution. So with the first compensation scheme, the Gini index of rural households is reduced by 4%, while with the second, we get a reduction in the Gini index of rural household of 7.3%. Moreover, we can establish a target of reduction of poverty rates at some groups, and we do so in a rural household. And we can get a reduction of 6% of the poverty rate if we use all the additional funds that we get with the second introduction of a carbon tax of $50 per ton. A relevant policy message of this exercise is that an issue which is very important is that we should define correctly the compensation package to get objectives in terms of reducing inequality or poverty. Even arriving to convert regressive taxes into progressive ones. The second application is for the European Union, and it consists of the combination of a work input-output table and a microsimulation model to analyze the effects of a carbon tax combined with several compensation schemes and analyzing the regressivity at the EU level. The scheme is very similar to the previous one, and there are two differences. The first is that we use cross-section data for household budget surveys for 23 European countries, and we combine it with work input-output tables. They allow us to collect production and final demand relationships among all sectors, and then to be able to translate the increase in prices given by the policy simulation, which is a potential reform corresponding to a tax of $25 per ton of CO2, not only to the households demanding or consuming, but through all the sectors, through the relationships that they have. And we translate demands, and we also translate prices to calculate new consumption after tax, to compute several indicators needed to say something about inequality or regressivity or redistribution. And we compare the tax burden relative to total expenditure with and without transfer in the count of affected households. This is one of them, which is we can observe that the effect of climate policy are the introduction of some costs affecting households very heterogeneously across different dimensions: income distribution, consumption patterns, structure of production, location of the household. The combination of data at different levels of aggregation allows analyzing the effect of the policies on households once we have the household budget survey, in order to see the effects of these policies before or after defining a scheme of transfer, a scheme of redistribution. In this slide, the crucial message is that it's convenient to analyze and decompose the heterogeneous effects in the case of trying to design policies which are going to be common across countries. The second slide, in this second slide, we compare the results of the different transfer designs after the effects of the price increases are transmitted to demand of each households and their effects on inequality. So there are, with no redistribution at all of the new tax, with national schemes of redistribution, with European scheme of redistribution, or with very specific targeted transfer accounting for different effects for different individuals in different countries. So the policy message here is that when designing these common climate policies affecting different countries and different individuals within the countries, it's necessary to define compensation transfer, adequate compensation transfer to get targets of the policy. And you can see here that situations where the tax without redistribution is completely regressive could achieve progressive redistributions when the transfer is designed. The third application is to answer a question of whether we can use inflation to say something about inequality. The retail price index is the main measure of inflation in most countries. We can think about it changing the cost of buying a very large shopping basket of goods containing the purchase of all these goods made by a typical household. That's how the Institute of Statistics gives the inflation. But we wonder whether there is a typical household and then an average basket of goods. And if we look deep at different consumption items, we can see that there is no chance to have an average household and an average basket of goods. So a world of food or fuel for housing or fuel for transport, we can see that a household at different deciles of the distribution of income consume very different amounts of these goods, amounts in terms of its total expenditure. So the message here is that climate change, climate policies, which are going to affect prices of goods, some of them necessities as food, electricity, gas, could produce undesired inequality direct effects through their increasing in prices, but also indirect effects through average inflation. If we look at the average, we can see that there is not that there is no important differences. So the retail price index and the price index computed with the household budget surveys on average don't produce, at least when the demand pattern of the household is not changing a lot. And we go to the COVID here and look at whether there was increase in food and fuel for housing in the expenditure of the households, and most affected the poor households because of the composition of the basket. The food increased 20%, but over a basket of 20% for poor or a basket of 12% for rich. And energy for housing increases 14% on a basket where for the poor it represents 8% of total expenditure, on the rich represent only 3%. So huge price increases of both goods could affect very differently at different parts of the distribution. And then we have here that there are important consequences in terms of inequality. The effect of inflation is significantly different in 2020 at different income levels. And it's very significantly different. The National Institute of Statistics computed inflation at minus 0.5% in 2020, while we calculate that there was positive inflation more than 1% for the poor, and the difference in inflation between poor and rich accounts for about 1 percentage point on average. So it's very, very important. The fourth application and the final exercise that is published by Jens Sewell, Thomas Turner, and Erich Turner shows measure of attitudes toward carbon taxation and other environmental policy instruments in Sweden using a survey with a sample of the population as well as members of a large political movement that protests fuel taxes. The first set of results in the slides intend to measure factors affecting the effectiveness as well as other sides of the policies. And the main message of these slides is that income plays no role at all when measuring these dimensions. The final slide, the second slide, tries to identify if in the two samples, the representative one and the protesters, there are differences. And the results we saw is that fee and dividend only gets moderate support from both populations, while earmarking for clean energy to reduce emissions get strong support for both subpopulations. So, as a policy message, there appear similarities and differences between the representative and protester samples. Many of the protesters are concerned about climate change and want climate policy, even if they tend to prefer some different policies of those preferred by the representative sample, which we should take into account if we like to get success in these kind of policies. My final slides, final thoughts are that there are some messages for analyzing heterogeneity in the samples through the lens of microdata or microsimulation. That combination of data is very important. That it's very important to the design of the policies to get the objectives, either in inequality or in compensating vulnerable groups or in reducing poverty or in combining opponents of the policy. And it's necessary not only to look at aspects related to the income distribution, because prices could also play an important role in increasing inequality at this moment in which after the third quarter of 2021, prices have been increasing a lot. And after the invasion of Ukraine in February 2022, prices are going up and up, affecting normally poor people. And the future of this is that we can use these tools in reverse. So we can define, as in the exercise in Mexico, an objective and get the price increase to achieve it and get the design of the policy to achieve the objective. Or in application 4, we can define a probabilistic objective and find the economic or socio-demographic variables, trying to identify groups or thresholds of variables that are supporting the policies. And the second, of course, is that we need better integration of the tools with aggregate information. Many thanks.
Thank you very much, José. Are there any very pressing questions to either of the talks?